Hi everyone, welcome to this webinar. I'm Zara and today we present to you Intro to Deep Learning. This webinar we have a very special guest who is Matteo Testi, who is the founder of Deep Learning Italia. So let's welcome Matteo.
Thank you. Thank you for the invitation.
Hi Matteo, how are you doing?
Not bad.
So it's great to have you here. Could you just give me a little outline of what you're going to be talking about today, and then you can start?
Yeah, okay. Just a brief introduction of deep learning, why deep learning became famous, the reason in the technical way, for example, hardware, the reason in the other way, for example, Google DeepMind, and different use cases in different industry.
All right, so you can go ahead with your talk. Best of luck, and the stage is yours.
Thank you. Okay, thank you for the invitation. As I said, I'm Matteo Testi, founder of Deep Learning Italia, and with my company we manage training in Italy, and we are AI factory. Okay, I did this presentation for high level, so you can understand everything and the reason why deep learning became famous in the last 5 years. I like to start with this phrase from Andrew Ng. So years ago, electricity transformed every major industry. Now, artificial intelligence, but in this case, deep learning, have the advance to transform every major sector in incoming years. But before moving to deep learning, just get back and understand the artificial neural network. Artificial neural network was introduced in 1943 from these two researchers, and the goal was try to reproduce a neuron and the firing inside the brain in a mathematical way. So now we're talking about deep learning, but every single algorithm, model, or idea start in these years. So try to put the math inside our brain and try to understand how neurons works in a mathematical way. Okay, stop, wait. Okay, in this last 12 months, but I think in the last 5 years, artificial intelligence, machine learning, and deep learning have become a trend on Google. So not just for researchers, not just for scientists, but a lot of people around the world know about deep learning, know about machine learning and the power of machine learning. So a lot of people in Italy and around the world know about Siri is an AI model, a virtual assistant. And using this tool from Google Trends, you can check the buzzword of these three topics. But between 2006 and 2012, Geoffrey Hinton, one of the father of deep learning, finally paralyzing an artificial neural network. This could be easy in our time using GPU, but in this period was very important, because if you want to training a neural network, not deep neural network on CPU, you need a lot of time. So this way to parallelizing a neural network was very important for the first winter of AI. The second step, for the reason because deep learning became more effective, was in 2009 from Benjo. So you can check here the Google data center, and here in the same years the Stanford lab. The difference is quite easy. So the Google data center was 1,000 CPU, cost too much. And the same power of this Google data center was inside the 3 GPU in the Stanford lab. So if you want to summarizing the reason because deep learning became so famous, I think there are 3 reasons. Big data, because we have a lot of data, and this kind of algorithm want and need to get information from a lot of data. The power of GPU, so you can parallelizing your algorithms in a GPU. And another reason is, this is just an example here, dropout. So when you manage this kind of data, a lot of data like big data, for example, million and million of row, or million of image, and you have this deep neural network, so neural network with a lot of layer, you need to some kind of regularization inside. So for example, dropout, data augmentation, etc. Okay, another reason for the improving and the growing up of deep learning was framework. If you study this technology, I don't know, maybe 10 years ago, probably you start to program in neural network, not deep neural network, but neural network in MATLAB, for example. Or if you study this in 20 years ago, maybe C++. So if you want to write from scratch a deep neural network models, you spend a lot of time to programming everything. For example, forward pass and backward pass means element-wise multiplication in the forward pass and a partial derivative in the backward pass. If you think like I don't know, maybe a LSTM network or some kind of complex convolutional network, for example, Inception or ResNet, there are, I don't know, month and month of working just for write a code. So with the adventure of TensorFlow, Keras, PyTorch, this is, I think, this is the big, the most useful framework in deep learning, TensorFlow, Keras, and PyTorch. You can write a convolutional neural network in just one code. Okay, and now we understand, okay, why become effect. But the other reason is why became famous. From my point of view, became famous in 2016. Thank you for DeepMind on Alphago. So Alphago is a program that play Go. Was developed from a company called DeepMind, acquired by Google, so Google DeepMind now. In October in 2016, won with this guy, Lee Sedol, the master of worldwide of Go. This was a very successful goal for AI technology in general, because it was very difficult to manage an algorithm can handle all this possibility in this kind of play. So Google DeepMind, in this case, this software Alphago, using a Monte Carlo research algorithm to find the best move and try to predict which move I have to do to get the best possibility to win the play. Obviously, the training is so expensive, and was a very good challenge, but DeepMind did it. But DeepMind doesn't stop to innovate with Alphago. It's moving to another challenge. It's called AlphaZero. And in just 4 hours, this new AI model and all the knowledge from chess in history. So AlphaZero is the best version of Alphago, and the why it's become the best version of Alphago was because, as said as a bit, they don't using data from human games. So they AlphaZero training and try to understand this Go by itself. So play with itself. And this phrase from a grandmaster, Peter Nielsen, was very, very funny. I always wonder how it would be if a super species lands on the Earth and show us how they play chess. Now I know. So like AlphaZero is a super species. But after playing chess and Go, they move into another difficult stuff, like mastering real-time strategy in a game like StarCraft 2. So this was much difficult to the previous challenge, but in just a couple of weeks, AlphaStar won with every pro gamer in StarCraft. This was very difficult because this real-time gaming is not like only vision, Monte Carlo research. There are game theory. You have to know what your co-worker doing. It was very, very difficult. But the last challenge of DeepMind was AlphaFold in these years. This is the paper. And AlphaFold using vast genomic data to predict the structure protein. So this is very innovative for personalized medicine and create drugs for tumor or cancer and something like that. Okay, another important point for the growing up of deep learning was ImageNet. This competition, you have 1.2 million of training, 100,000 for test, and you have to recognize 1,000 of objects. So 10 years ago, this challenge was very, very difficult. Nobody get to end this challenge, try to doing the best, but the accuracy wasn't good. But after the first convolutional neural network was applied to this challenge, everybody using deep learning get 95% of accuracy. So, okay, last reason because deep learning is growing, I think, is, from my point of view, is Kaggle. So Kaggle is a website, and you can find data set, you can find competition. So some company have some problem, describe the future, describe the task, and give some revenue. For people who want to add to solve this task. Okay, but what is the difference from deep learning and traditional statistics model? So, from my opinion, is okay. Deep learning is end-to-end training without a specific feature. So this kind of model, deep learning especially, can spread in different GPU, different server, so can be scalable, easy scalable. And statistic can able high-dimensional data set. So if you're working with deep learning and you have 1,000 or million of columns of future, you have a big problem. Okay, so this graph, I think, represents very clearly the difference between AI, ML, and deep learning. So, as I say, my professor in university, artificial intelligence was the first name of this technology. Try to computer mimic behavior. But for example, if you show Google Maps to people, I don't know, now this is not artificial intelligence. but there are some kind of algorithm that help you to using Google Maps, for example. Machine learning is the ability to learn without specific programming. So I put my input, I said what will be my expected output, and this is what I'm doing. No, without if or else or any kind of regularization inside. Deep learning is inside machine learning, it's neural network. But during these years became so famous, and for this reason, a lot of people working and try to keep focus on deep learning. Okay, but what is intelligence? So intelligence is the ability to process information for the future decision. So our goal in AI in general is build an intelligence things for future prediction. Machine learning, deep learning in this case, try to teach an algorithm to take and extract information from the pattern and give an output for classification, prediction, and so on. So machine learning is a technique of to learn from data. Learn system to solve different tasks, speech recognition, object detection, and so on. Deep learning is a sub-area of machine learning. It's just neural network with a lot of layers and different data and regularization models. So statistics and machine learning, the difference is easy. Statistics is just an inference from a sample. Machine learning tries to generalize the prediction patterns. So to apply statistics, you have to have a deep knowledge. Usually you have a deep knowledge of the what you want to find. Usually, if you're using machine learning or deep learning, you have to have a knowledge in the stuff. So if you want to predict the stock market, obviously the knowledge of market can help to improve the algorithm, but you have to be a financial expert, for example. The difference between machine learning and deep learning, all algorithms can do the same things. In these times, deep learning kill every problem in AI. So if you want to solve a computer vision problem, you're using deep learning. If you want to try to predict a time series problem, or for example, NLP, you're using deep learning. But you have it used for sure. So if you want to use some kind of easy algorithm, can working very well as well. Okay, the deep learning task, you can do it is classification, clustering, and prediction. So for example, predict the market is a prediction task. A classification task, I want to recognize cats and dogs. Clustering is using an unsupervised task. So to clarify, classification and prediction is a supervised task. This means I have the label, so I know what is the expected output. So I know the image is a cat, my output is a dog. This is not the right choice. Go back and training a model until you get a dog. Prediction as well. I know the real price, and I want to minimize the mean square error. Clustering is an unsupervised task. So I don't know the label, and the algorithm help me to understand the data and try to the label and the pattern. Okay, after all these things about why deep learning became famous, why it's so powerful, why we have to use deep learning, just a bit limitation of deep learning. So this is an article, Understanding Deep Learning Requirement, Rethinking Generalization. Okay, this experiment is very easy. I'm trying to mismatching the label in my training set. This means the image from dog became banana. The image from trees became dogs. The image from dogs became trees, and so on and so forth. But what's happening if I'm doing this mismatching in my training set? Let's check. Okay, as we can imagine, the test set, validation set. So the part of my training I'm using for validation my algorithm. So I'm using I don't know 70% for training and 30% of test, or 20% for test and 10% for validation. So this validation and test are the data that my algorithm haven't seen. So in this kind of training test, I want to generalizing my algorithms. So as we can see, the training, the accuracy of my training is going down because I'm mismatching my label. So my dog became tree, tree became banana, banana became dogs, and so on and so forth. But obviously, my training gets always 100%. So this is very easy to understand because my training learn from my label. So my algorithm doesn't know this label is not a dog, but I change the label. So this is the problem. If I put rubbish in my input, my output, it's not flower. Okay, other problem from deep learning and the limitation is usually in this image is my training. So I'm trying to fit my model and change the hyperparameter to fit this landscape. I plot this in 2D because it's more easy to understand. But I'm doing my training, I put my training in production, so my classification works very well. Dog is dog, cats and cats, trees is trees, and so on. But in my real world, so I put, for example, this model in a real world application, and I got this problem. So this problem is maybe my landscape from real world is different. Maybe there are some kind of tree, it's similar to another things. Maybe some kind of dogs, it's similar to another things. So this is the problem. When you're training your data, big data, you haven't all the data that you will find in the real world. So this could be a problem. Okay, another big limitation is the noising perturbation. So if I training a CNN to this image, I got 97% of accuracy. But if I put some kind of perturbation, noising inside this image and trying to retraining my model, I got 80% of other things, ostrich. The first temple, second ostrich. So if I put some noising inside my image, I can mismatching, I can misclassification the image. But this it's happening in the brain and I think the attended have seen this image in color. So this happening in the brain, in the human brain as well. So I think in the first 2 seconds you check this image, okay, it's a color. But if you're focusing, this is not a color image. It's a black and white image. Just put some horizontal, diagonal line, red and blue. So you can check all the experiment for this neuroscience here. Okay, I got another big mistake in the same way we're talking in the previous slide. Was in 2015 from this engineer that put the photo of our friends in the Google photo, and they recognize this friend as a gorilla. So this could be a problem. So this was a misclassification. This is like this example is like this. So for some reason, the classification looks like the black people most similar to gorilla. Obviously, it's not true. So to summarize, the limitation of deep learning are they need big data, it's computational intensive, it's a black box requiring expert, and there are some particular issues. Okay, there are different applications. I try to show a couple of, I think, useful application with some cool video, but deep learning AI you can apply in any kind of sector: prediction analyst, customer service, risk management, fraud detection, manufacturing, agriculture, whatever you want, finance, healthcare. Okay, I think this is a very cool example from a self-driving car. So using an AI model to driving a car, and just show you this. Okay, keep in mind, in this kind of real-world application, it's just not one model. So to driving a car, there are a lot of models. For example, computer vision to see the street, to see the tree, and whatever you need to drive a car. You need time series algorithm, for example, LSTM, to understand what you did in the step before and previously. You need the reinforcement learning to check all the possibilities. So when you're working in this kind of real world application, it's not just one model to driving a car. Okay, another cool use case is from inbound logistics. I think the most famous application is on Amazon Go. So you can go to the market without any staff and employee, check, take whatever you want, and Amazon recognize your face and take out from your credit app the bill. So let's check this example, not from Amazon Go, but from another different task in China. Okay, let's move on. Okay, JP Morgan as well did some research in AI, and they made a software that can handle thousands of hours to check the commercial agreement from the lawyer office. And they spend a few seconds to check all this commercial agreement and save 360,000 hours per year. Okay, and also the Bank of America create a Erica, a virtual assistant that can help the client to monitoring, tracking, lock and unlock debit card, and so on. So like a virtual assistant or chatbot if you want. My company, Deep Learning Italia, in 2006 created this software, sentiment analysis, take data from Twitter and any kind of social or blog, and can give you sentiment. So understand the text on the comment and give the label from neutral, negative, and positive. So just to check what people think about Deep Learning Italia in Twitter or on Facebook. Another cool experiment we did with Deep Learning Italia was a competition in Kaggle in 2017. And we developed a lung cancer detection tool that can take the T-seq scanner and using a ResNet can get 75 of accuracy to predict cancer or not cancer. The last project that keep going, it's ongoing, is Icaro solution. This is for financial market. It's a deep learning for asset allocation. Obviously, we're using a lot of model to try to predict the best combination strategy to put your money in different assets, for example, commodity on action. Thank you. If you have any question. Any question?
Thanks a lot, Matteo, for that. It was a great talk. So we have one question here. What do you think about Neuralink, which is Elon Musk's startup?
I can't speak about Elon Musk.
Just okay. You can give your opinions, maybe.
Yeah. Okay. This, I think, this is the next step of AI. Try to link the human brain with some kind of artificial neural network. So there are a lot kind of study to try to controlling robot and stuff using Neuralink. But as we can check in the track record of Elon Musk, this guy start with innovation and try to put this innovation forward to 10 years. So the Mars problem, Mars project as well. So going to Mars is another great example. So Neuralink, it's become from neuroscience. So try to link the human brain with AI stuff, but it's just theory and some kind of experiment.
Okay, I have one more question. So what do you think will be the relationship in the future of deep learning and artificial general intelligence?
The link between deep learning and artificial intelligence?
In the future, like what do you think, like deep learning, what role would deep learning play in the future, especially for artificial general intelligence?
Okay, I think in the incoming 10 years, every sector will use AI and will be used like a website. So every commercial stuff or every people have a website to promote their business. So will be some kind of natural technology that everybody know, not in the technical way, but know you can use AI in medicine, you can use AI in finance. So I think in the incoming 10 years, everybody know about AI, and a lot of company from biotechnology to finance to manufacturing will use AI as a commodity, as you can use everything.
So you think in the next 10 years we'll have super intelligence, like you think humans will machines will replace humans, like we'll see robots replacing us in the next 10 years? Considering
No. General intelligence, I think it's a concept that will be in more years, because general intelligence at the moment will study AI to solve one task.
Mm-hmm.
If I'm training my model to recognize lung cancer detection, I can't use to recognize another type of tumors. If I'm using the Erica from Bank of America, I can use this virtual assistant for medical doctor. So a general intelligence, I think it's a concept that will be in a decade, more than a decade, because it's very difficult to doing a general intelligence that can solve and try to figure out any kind of problem.
So our jobs are safe for the next 10 years at least.
Yeah, at least 10 years.
All right. Thanks a lot for your talk, Matteo, and we hope we can see you again here in the future. And best of luck for whatever you're doing right now. And we hope at least you don't replace our jobs in the next 10 years.
Thank you. Bye. Thank you for the invitation.
Bye-bye.
Bye.
Thank you everyone for tuning in today. Stay tuned next week. We will be coming up with another webinar. Everyone have a great night. Bye-bye.